Hi, everybody. Okay. So I usually like to gauge the audience in terms of like technical understanding. So it helps me like better present for everyone in my audience. So can I see a raise of hands of people that know? We'll go top down. Python. Yeah. C. Assembly. Oh damn. Okay. You guys are smart. Okay. Cool. This is intimidating. Okay. Um. Okay. Sweet. So. Yeah. So I usually like to start off talking about something more fun. So I got really interested in like malware analysis and researching malware after traveling a little bit and stuff like that. After meeting some more researchers. So really just taking apart the binary and seeing what's there. So I don't know if you guys are like me, but taking a look at a piece of malware, seeing how it works, or seeing how people write it is very, very interesting to me and stuff like that. So, yeah. And then more recently, I'm a security contractor as well. So I've been contracted to create proprietary rules based on CVEs and looking at different ransomwares and stuff like that. And this one was like more so discovered recently. I thought it was really cool. Most ransomware, it says you need to pay up. This one specifically, they force you to play a demo for 1 hour, and then they unlock your files. It's not a very clever piece of ransomware because in the actual binary itself, you can derive the key and just be okay. But there's some technical feats that have to get done to do that. But you can also just download the thing to unlock your computer. And then, like most talks start, these are my words. These aren't any of my employers or anyone who's hired me and stuff like that. This is just me talking and sharing with you what I've learned and my experience. Okay, so as I said before, my name is Chris Magistrado. I was one of the co-founders of the Hacking Club at SF State. Started it in 2016. It's still going strong. We have different members come out all the time. It's really great to see people passionate about security and really interested in learning more and being excited about learning. I took at SF State, I went to the computer science department, and I really saw that there was a need for other types of careers that the curriculum provided. A lot of the curriculum seems like it's more geared towards web development. You don't really get into deeper level architecture and things like that. And I really wanted to show that there was obviously a career choice outside of the given path and stuff like that. So I was very happy to do that. I volunteered at Bay Threat, that doesn't exist anymore. BSides Las Vegas, CCC Camp, and which is really fun. Definitely check out. And then SHA 2017 as well, which I also spoke at. And I've done a few different speaking engagements as well. So yeah, that's me. Okay, so let's get into the details. So we'll be talking about the reason for everything. So we have to go over side channel attacks, speculative execution, and then out of order operations. Just for the basis, how many people are familiar with any one of those concepts? Okay, all right, sweet. So I'll try to like go by that pretty quickly then, and then the vulnerabilities, Spectre and Meltdown, exploitation, mitigation, and then POC and demo. I'll pray to the demo gods for that. Okay, so who discovered the bug? So it was independent researchers of multiple parties, 2GRAS, as well as the Google Project Zero, which they specifically just do research. Okay, so we'll go over side channel attacks. Because most people know it, we'll go over this pretty quickly so we can get to more of the fun stuff. So you can store data in different locations and stuff like that. So what a side channel attack via cache is, also known as like flush and reload, it allows you to do something and then store some information in cache. And then what you do is you check to see, hey, is this variable or this thing in cache? And check to see the time it takes for you to receive that. So you time how long it takes you to receive the item or the piece of data, right? The information. So if it happens super quickly, that means it's probably in cache somewhere, whether it be L1, L2, L3. And if it takes a little bit longer relative to the time it takes you to pull it in cache, then it's probably in RAM and it's not there. The reason this is important is because this is how you determine if you can pull information. Basically, because of these vulnerability bugs, you're able to pull anything that's stored in a cache registry. And if it's on the core, then you're able to just keep pulling all of it, even if it's not your process, even if it's not your VM. So this brings us to out-of-order execution. Show of hands of how many people know this. Okay, cool. I'll spend a little bit of time on this one. So so when we're programming, we believe that, okay, it goes in the process that we are actually writing the code in. In reality, this is not entirely the case. What happens is, for optimization, the people that design the CPU architectures, or a lot of them, they incorporated out-of-order execution to make programs run a lot faster and quicker. And they started doing this a while ago, and we'll talk about that as well. What this does is, if you can look here and see, it actually depends on if a variable is required prior to or not, in which case it'll just run it anyways. And this is important because if it runs it anyways, it will put it in cache, just in case it needs it. We're doing time. Okay. So Spectre and speculative execution. So the same exact thing that it does with out-of-order execution. Again, out-of-order execution, it's reliance on certain variables and stuff like that. So if you don't need the variable, if a variable is not required previously, and you have two different ones, it'll just do it for optimization. Now for speculative execution, what happens is you have an if statement, and then it just says, all right, fuck it. Well, we'll just run the other stuff anyways, because the CPU is just chilling, it's hanging out, and it has the resources to do this. So instead of waiting for that if statement to finish, it will just start doing the other stuff. And that other stuff could start putting stuff in the cache, and then you can start pulling information from there via the vulnerabilities. It's good to note that there's two types of variants for Spectre. You have variant 1, which bounds check bypass, and this is specific to binaries. So to patch this and mitigate this, you really have to worry about how a binary is compiled. So this is a little bit different, and this is actually the more difficult of the 3 CVEs to be patched. Variant 2 is just branch target interjection, and there have been a lot of patches for that specifically, and a lot easier to patch. This allows you to read memory from processor, hypervisors, as well as in the kernel. Okay, meltdown. So this causes an exception, or you cause an exception, right? So whether it be invalid memory or division 0 something, and the data is saved to cache because it accesses that level of kernel. It references the memory it is fetched into registry, and then it also just stores it in cache, just in case. And that's where it fucks up. That's where you can start pulling it. During out-of-order execution, the registry memory contents are never committed, but it is saved in cache, though. So you get to pull it. Okay. So now, Meltdown versus Spectrum. I'd like to very much thank Jake Williams of Sans Analyst. He did a really, really great presentation on this, and there was a lot of help from there. So Meltdown specifically attacks the kernel memory and read. Spectrum, not as much. Spectrum is usually attributed to different types of browser exploitation. So it's specifically, some of the future exploits that we're probably going to see are going to be written in JavaScript, probably on a malicious page. And then once a browser hits it that's vulnerable, it can dump everything that's in that browser. So those are credentials, passwords, anything that browser has, it can also pull. And then affected chips, there's a lot of things that are affected by this. So these are the things. If you have any of these, you're probably affected. And I will say, like, a lot of people have come forward of these communities and have actually put patches and created patches for everyone. But some of them, they took a little bit longer than others. I don't want to point names or fingers because you guys probably work for one of these, I'm sure. But yeah. So the next question is, like, how long has this been around? So it's been around for a little while, ever since order of execution, as well out of order execution, as well as speculative execution has been around. So for Intel, that's 1995. You guys know what happened in 1995? Like, this was the image of what we were. So it was a little. It's been around for a minute. So ways to exploit Spectrum. Browser leaks, JavaScript execution off a malicious page will do the trick. Start pulling everything that you have in your browser. It doesn't matter if you logged into another website, if you have other credential keys, session keys, boom, you got them. But to secure yourself, you can update your browser. And, we always update our browsers when we got a ridiculous amount of tabs open, right? Just get rid of all of them, especially if it's in incognito mode, right? You just get them right back. And then you can also leak module addresses, which really fucks up ASLR. Anyone ever played with that before? Yes, that's really fun. That's really fun stuff to do. Okay, and then again by Jake Williams, Spectre can be used to determine the address of a module memory and bypass ASLR. So there's a little neat trick you can do. How many people are familiar with ASLR? All right, yeah, this is a great audience. All right, so how many people are familiar with bypassing ASLR? Mildly. Okay. So I was gonna say for people who don't know. Well, for people that don't know what ASLR is, every time you run a program, the memory addresses are like quote unquote randomized. But what you can do is you can say, okay, like tell me where the base address of this library is. And then you're like, okay, cool. And then you say, okay, I know that libc, it's usually returned to libc. I know that libc is here at this location. So how many bytes towards a specific function is? So so you would calculate that relative to this, and then you would execute that. So usually you can be like a execute, and then you can execute shell, and then somewhere in the binary you put your string for bin bash or bin sh, and then boom, you get the access. Cool. All right, so ways to exploit Meltdown. Privileged escalation as well as container paravirtual hypervisor escapes work. So this is a little bit terrifying because if you are a cloud provider, have your servers on a cloud, and that's the core that you're sharing with other people, it can start pulling information that you don't want to have gone. So as far as privilege escalation, any unpatched hacker can just dump physical memory, and then you can use a tool like volatility to have some real fun. Alternatively, if you're a cloud and a hacker accesses other people's VMs, it's if you guys are using the same core, you're gonna have some fun. Yeah, Cardi B, party gang. All right. So mitigation. So AWS, Azure, Google Platform, and Cloud Passage. Shout out to our sponsors. You'll be all right. So I know a gentleman named Alex M. I'm not going to slaughter his last name, and Sean Nicholson are both security engineers that wrote some good information about Cloud Passages, how they're handling it. Documentation for the Google Cloud's also really, really good in terms of how they handled it. They did Project Zero, so they found the vulnerability, so they got on it. AWS and Windows is cool too. The other ones, it really depends. You're gonna have to do some research to see if your cloud provider is actually handling and addressing the situation. It's interesting. So Google actually fixed the mitigation. So they handled what was it? The variant 2 for Spectrum by, let me do it again. They handled it through a software update or something like that. I don't recall exactly. Was that live migration? A little bit more on that. Okay. Did everyone catch that? Mostly. No. We'll link you. How about that? Sorry, it's been a long morning, but for variant 1, it's been a little bit more difficult for them. They said that it has to do with patching binaries specifically that are running on the systems, and they have different levels of mitigation to protect you by the way they have their architecture set up. So that's, again, I think that's pretty difficult to have to handle. Is like if someone's running binary in your things and you have to secure them. That's pretty cool, but. As more for mitigation, this is only like half the list of vendors that have come out to actually have security bulletins on the matter and other articles, and it's really great. They're actually really good reads. If you picked up anything I'm talking about, you'll be able to pick up the rest of these like really easily. Okay, and then more on mitigation. So for the browsers, as long as Chrome, it's better than 64. Mozilla Firefox, 57. Internet Explorer, so the thing about Microsoft CVEs and portal.microsoft and TechNet, it's, at least when it comes to Internet Explorer, I don't think they tell you exactly what versions are patched and stuff like that. They just say which versions are affected and then just say to update it. So yeah, if you think the Mitre CVEs and the NVD ones are bad, anything specific to a version of IE, it's difficult because it's just like 11's affected, 10's affected, Edge is affected. It's like, what? And then yeah, and then any other software, just if you're updating it, you'll probably be okay. Intel chips. So these are the ones that are affected. It's freaking everything, pretty much dating back to 1995. So. And they most recently they've released other patches and stuff like that, so you can run this microcode and update your firmware, and then you'll be okay for the time being. ARM chips, the ones that are affected, R7, R8, these ones of 5 A, and but the Cortex M series are not affected. Yay! Woohoo! And then you can update via the ARM community. And the ARM community has been very forthcoming in talking about updates and stuff like that. They approached it very quickly and handled it very nicely. Some other people have taken a little while. AMD, as of like 5 days ago, said they're still working on it. You guys, does anybody know if AMD patches have been updated and applied? Maybe? Kinda, or yes? Okay. Okay, beautiful. So, okay, so yeah, if you're not on Windows 10, go to the AMD site. He said they pushed it last week, so it's been it's taking them a little while because the vulnerability was talked about in January of this year. So, all right, what are we doing on time? We're doing some time. All right, let's go to demo time. All right, let's see if everything breaks. Can you see this? No. Let's see. How do I do this? You see a car? Let me try this. Does anyone have any questions? I will try to answer. But this will probably be an open forum so we can all get this correct information. It's a nice one. It's one I can't afford and don't have enough money to afford, but I'll dream and look at it while I'm at work. But it's a Lamborghini. Anyone have any questions about the talk? There you go. Mirror displays. There. Okay. Okay. Bigger? half my keys don't work on my laptop, so this is the next solution until I fix it. Okay, so like all other speakers in security, I was setting up my presentation very close to presentation time. I started last night and finished about 30 minutes before I came in here. So I wanted to say, like, reading and understanding a POC, given I didn't allocate the correct time to actually create one, I apologize for that. But reading other people's POCs and actually understanding it, it was a little bit daunting when they don't have enough time to do it. But it was very freaking amazing to be able to learn. There we go. It was very fun to learn and just play with other people. This guy, I'm gonna link you guys. He just did it live. He wrote the entire thing live on live stream or whatever, and he just killed it. That I'm so impressed. I want to be able to do that. But here. So. Okay, what this? Would you guys like to see the code, or would you like just to see it run? Run it? Run it? Run it? All right. Break. Cool. Okay. So what's happening is we are putting a secret. So, wow. Okay. We're putting a secret in the kernel space. So it's not supposed to be accessible, but because of speculative execution, and we can tell the amount of time that it takes, we're able to pull it. The message is, L, do you know gods of death like apples, love apples? So, yes. And these are the locations as well. So this is what I have. The POC is online. I will also link that, but it's an easy one to find and stuff like that. I was really trying to find some JavaScript ones because I have not been able to see too many, but I think that's going to be the next level of attack in terms of malware that we're going to be seeing in terms of like exploit kits and ransomware, or entry of ransomware. So, all right, that's all I have. I hope you guys enjoyed the presentation. Yes, and then we can do questions, and I also have bunch of resources. Check out nullsec.org. It's a great website if you want to get your hands dirty in some binaries, either taking them apart or developing your own POC code. We do fun things like writing our own encryptors and decryptors and stuff like that. So we'll like set up like little environments where we can write our own little ransomware stuff and just like do that. All legitimately, systems we own, things like that. So we also are live on IRC as well. So thank you guys for coming out.